us from Remote Lab South is right in the middle of midterms, so won't be joining us. But hello to him and best wishes on a successful round of midterms. So welcome. This is our Halloween Hootenanny, our Halloween episode of of the FPGA
Got my
meetup.
costume.
Right on. Thank you. And what we do at this meeting, we usually go around, do a round table of what we've been up to, what we have planned for the next little bit of time, usually a week. If we have any resources that we need, and if we're suffering from any roadblocks in our way. So I will go ahead and I'll go ahead and let Ed lead us off. I think you have some things to report and some
Yeah.
questions. So you have the floor.
Okay. Hi, my name is Ed Friesman, a PhD student at UNLV. I've been recently awarded by Michelle was kind enough to give me an on Pluto, which I've been playing with and implementing some things with to experiment and my first task I felt like get some low-hanging fruit was to create like a little Satnog station with it and use it to demo to our cube. We have a CubeSat proposal called RebelSat that we have been in. It's in the CLSI phase for about 3 years now. It's difficult because you have students turning over and over. So like the software teams and the comms teams are a lot of undergraduates who are interested and willing, but there's no like through line manager who's kind of like telling everybody, hey, here's where you need to go. And if you don't understand this, here's how I can show you this to get you up to speed. So I was offering with the Batya was our team lead, as the whole project lead right now. And she was very, I mentioned to her, like, hey, if I show you how to use like a Satnog's ground station for tracking, we can get a couple things, orbital elements in, how to track satellites, how to find out how to use the basic Satnog's client. Their station, we have actually a Yagi antenna on the roof of our SEB building, but they're using it for TinyGS, so it's a little different. So they're using TinyGS LoRa packet scanning. So I wanted to just show them like here's how the Satnogs works to get some learn to practice something pretty straightforward with the Adon Pluto, and also give our faculty something to learn with. My next goal was to take the Adon Pluto and use it as a GNU radio class DVB-S2 receiver. And then once I was sure, had a pretty good idea of how everything, all the parts were there and it was working, I wanted to move to the FPGA because there's a Zinc 7000 on system on a chip on that unit. So I could feel like I could take a lot of the ORI FPGA stuff. And then once I had a good baseline of like, here's what it looks like when it's working, and here's what all my signals are, and here's my basic test profile. Now let's try the FPGA. And then I feel like, because the FPGA is probably not going to work right out of the box. Like when I do it, I will almost certainly screw something up. So I figured like having a baseline where it's like, oh, here's what it looks like when it works using GNU radio. Here's why I can compare. And GNU radio is easy to like source and sync elements so you can kind of get files and kind of get an idea of like, here's what the midterm points look like. And it's good for creating a test benchmark so you can troubleshoot on other systems. The one question I had for the group was I'm still not funded for this, unfortunately, because it just falls right into such an interdisciplinary niche, and the computer science department doesn't really, none of the professors are really that interested in it. So I'm trying to do this with spending as little money as possible out of the gate. So one thing I have is I have this nice little RCA DVB antenna that they use for taking DVB-S2 signals out of the UHF frequencies. And my first question for the group was just kind of if I got the decoder for this to work, if I could get DVB stuff on my receiver through a Dom Pluto, how different is that from the setup that I would need to actually like pull from a satellite receiver? Like from once it gets into the Adon Pluto, once I get off of it through the antenna, how much does that implementation change? In other words, can I test a lot of things that would be useful to the FPGA group if I just had this? And that's my first question. That's basically.
Okay, so anybody that wants to step in and add to this, please do. Any antenna will work because what you're at the FPGA, what you're trying to measure, I believe, is the baseband functionality. So, like, can you get it all the way to the I's and Q's, and then if you have to work at IF, some frequency that the Pluto is capable of, then that's what we do here. So for the final implementation, like whether it's terrestrial or on a spacecraft, there's going to be additional radio frequency and antenna components, which will cost money. Um, and so the answer is absolutely yes. With what you have, from what I can tell, looking at that looks quite useful without knowing if there's any um, details that would prevent it. And so I'm going to defer to the rest of the people here to con to correct me if I'm wrong, or to give you their take on it.
I have a question about it.
Mm-hmm.
Is that you call it an antenna? Is it a whole receiver? What's on the other end of it besides the?
I actually just pulled this off of our a TV today, so I gotta look at the spec sheet to see what comes out. It's got an F coaxial connector at the back end of it.
Okay, that's for the satellite dish, I guess.
Yeah. So it basically, as it stands, it goes straight here into the CFI coaxial on the TV. So I think this is a receiver unit.
Yeah,
But I wanted to double check look up the part number and double check on the spec sheet to be sure exactly what's coming out of here.
I'm not
But I
familiar.
believe it is a receiver unit. Sorry.
So it's video coming out of that connector, right? If it goes direct to the TV.
Correct.
Okay.
So it has to be decoding the DVB signal and then
Already decoding. Yeah. Okay. I see what you're saying.
Yeah, that's a good point.
Yeah, you're right. So it's already doing the work that I want.
If it doesn't have a USB interface or something like that that would let you have access to the decoded digits before they get to be video,
right,
then it might not be super useful.
And see if there's if you can get IQs somewhere. Like, I don't know what the processing units are, but you're going to have a receiver unit with some sort of down conversion and then going into the DVB chip, right?
Okay.
So presumably. So I don't know how that looks inside, but you might be able to tap off the outputs of the receiver before they go into the processing.
Okay. Yeah, that's a fair. I just pulled this out today. I was just thinking, trying to get it ready for the meeting just so I could show you what it looked like. But you're right. I think that's okay. Okay, I'll have to look up the spec sheet and see exactly what it's pulling out, but that's a good point. I have other antennas available, so this was just something that occurred to me this morning.
I think the idea is a good one. We've made significant progress using commercial receivers that are designed for DVB S2. Got to get all those letters in there because they all matter. But there are things to consider. Like, a lot of them won't go as low in a symbol rate as we are likely to want to go for our bandwidth limitations. And some of them may or may not be able to do the GSE generic. What's the S stand for? It's the generic stream encapsulation, which is how we handle data over what was originally intended to be a video system. That's also standard now, but wasn't standard originally. And so lots of older receivers don't have that capability, and so on. So you have to be a little careful. We ended up having to pick some fairly expensive receivers that were intended for commercial use in order to get the kinds of capabilities we wanted.
Yeah, I'd prefer to be as much have the antenna just do the antenna part and as little have all the digital stuff in the Pluto, because that way A, I have the most control over it, and B, we can test the most things. So that's my goal. A lot of the commercial receivers, obviously, the whole point is they figure the client wants the exact opposite. They want as little of the encoding done as possible. So I have some other antennas that are a little more raw. Some that's just I have a Yagi that I cobbled together. I'm not the craftiest person, which is why I moved from EE to CS. But yeah, so that's probably, in the long run, that's probably where I'm gonna have to go. I just kind of wanted to get, but you're right. As long as I feel comfortable now that if I can get to the baseband, then I can start doing the digital processing, and hopefully, as soon as that's up, then I'll plug in on the ORI, the FPGA Slack group, and we can start testing some things. Because I feel like there's a lot of power in that little Pluto that I think we can use to like start benchmarking. And I've been seeing on the chat, there's a lot on the chat, obviously, but I've been seeing a lot of stuff where people weren't sure whether it was an implementation thing or one particular person's setup was causing issues. Like there were some people talking about like, oh, I got it working on my end, but we're not sure where there seem to be some errors that we need to track down.
That always happens whenever
Yeah.
it works in one place and doesn't work in another place. You have to do some debugging
Yeah.
to figure out what the problem is.
Yeah, but at least with one more unit, we can like maybe we can track some issues down that are currently out there floating. At least it gives us one more station to check out and test some things. So,
Yeah,
um,
awesome.
so that's where my basic plan is just get the basics of it up ready to do a little demo for our comms group at CubeSat, and then take this to the DVB S2 receiver. Now, is the S2X a lot more complicated? Is it a lot more complicated, or I've been looking through the thing and I'm trying to see, is it a quantum leap above it, or is
No,
it?
no,
Okay.
it really isn't. The difference between S2 and S2X is primarily it's not just this difference, but the main value of the spec is that it provides additional modulation encoding pairs. So the table expands in order to give very low SNR. So at the very low end, so very low SNR down to neg 10, I think. And at the high end, at very much more complicated modulation encoding pairs for high throughput satellites or HTS. The original DVB-S2 spec over time, the ends in the curve that sort of follows the capacity curve. There was a need for more, and so that's why DVB-S2X came out. The X stands for just extension. Now there are some other things that had to change. So anytime you add new things, so if you read through it carefully, which it sounds like you are, then you'll see that there's bits here and registers there and restrictions that are scattered around. So no, not a quantum leap. So this is the S2X is not the equivalent of like a DVB S3, for instance. So some care needs to be done in implementing the extension. But yeah, it's the main value is to add more modulation encoding pairs so that you can go further up and down essentially the capacity curve.
Okay, and forgive me for some of the questions. I've been really drinking from the fire hose for the
Oh
last
yeah,
like
there's
month and a half, and so there's been a lot of things where I'm like, "Ooh, I gotta learn that." Oh, she's gotta brush
yep,
up on that too. So it's been fun, but it's been
good.
like, yeah. So, but forgive me for like if I ask some questions where it's like seems kind of basic. There's some things where I'm still getting all the pieces lined up. So I really appreciate all the help, and yeah, it's looking. I'm very interested to see how I can push this in the next couple of weeks
Yeah,
and
yeah.
get some things up and running.
Never apologize for asking questions. There's no possible way for one person to really know all of even a small bit of this. And what we're dealing with is very interdisciplinary. Like I think you already used that word, and it's very true. So it's pretty rare to find somebody that's really, really good at FPGA design, for instance, that also wants to do open source work. And it's pretty rare to find somebody with digital comms experience that wants to do open source work, and to have people that are comfortable with both is an even smaller group. So there's no possible way for us to know everything. This is a huge field and it changes and is non-trivial. So yeah, ask away. And we'll, in between all of us that are all pitching in, if we don't know the answer, we will do our very best to find the person that does. I'm very much looking forward to hearing how the demo goes. And now you mentioned that the RebelSat this is now 3 years and it's been in CLSI stage.
Correct.
It sounds like you might have a shot at maybe helping to push this further along. Is that it's sort of
I'm trying. It's hard because I got to balance it with my PhD dissertation, and it's just like unfortunately that swamps everything else.
yeah.
And I'm not a really great multitasker, to be honest. I generally tend to be like, okay, give me one thing to attack, and I'll do pretty well. But start splitting me up, and I'm not
Yeah.
good at that.
Okay.
So it's just been, I want to help them as much as I can because I see where the issues are. It's just basically nobody has enough time and there's not enough continuity in the program.
Yeah.
And given those restrictions, it's amazing. I think it's really impressive what they have done and what the groups have achieved. But it's just like I feel like to get them over the hump, they kind of need somebody to. They needed a professor to take ownership of it, and none of them have done that, which is kind of disappointing because the one guy who did, who was looking at it, was kind of looking to like take it over and make it part of his lab. And so he made like all this, there was all this politics and it was really lame. And he like insisted that everybody do things and that he get the credit on everything that was published from it. And he kind of just it was really sad because he was the opposite of what you want in leading that thing. But they kind of need somebody on staff who's willing to kind of like take it by the hand and make sure they know where all the GitHub keys are buried and everything and all the just keep people moving. Because there have been times where people have been like, "Where's what? I can't log into this thing," and it's like I know it, and so it's just they needed somebody to be continuing, and it's just not fair to expect the students to do it because just by the time they learn enough to be useful at it, they graduate.
Yeah.
And so they're gone. And so then we got to start it and we got to retry it all over again. And it's just with something that's as detail oriented as that, when you've got like flight software and communications and power units and the actual payload itself, it's just
Yeah.
somebody needs to be like kind of consistently semester to semester holding the thing. A professor would be well suited for that, but none of them have really stepped up and done that. They just kind of, and it's just, which is kind of a shame. Which is, I mean, it's a testament to how good some of the students are that they've managed to pull through despite that. But it's kind of also disappointing that it's like, oh, come on, come on. You just need somebody to kind of keep these guys, get the new guys up to speed and keep the project rolling because momentum is a thing.
Yeah, it is. Yeah, I think
It's
you've summarized probably a very common problem across the university landscape, and not just for satellite projects, but for anything that's longer than a semester. It's really hard. And a lot of times these projects are used for learning first, and for completion is not necessary as a success criteria. That starting over every semester and getting a little further is perfectly fine by the university. It's being used to successfully teach students on something that's very popular and fun, and can transfer good skills. It's just that
yeah,
I'm more in favor of like they should it's like it's a project, therefore it should be finished by the students, and that's even better. Um, so
yeah.
there's a kind of a, a little bit of a tension between a purely academic approach and a getting things done, you know, project goals. I'm not sure what the right word is, but
Yeah.
a
No,
more
there
practical
needs to be
approach.
some closure or something. There needs to be a sense of like we got this done.
Yeah, and
And
yeah,
it's just
academic approach does not require closure whatsoever. As long as it's used, it can be used over and over again forever to as curriculum.
and the thing is, in that on that level, it succeeded. I feel like a lot of people have learned a lot about satellites and how to design satellites and space missions from the project over the years. So in that sense, it's a successful instance. But I've been around long enough where it's like they still haven't had a Nevada school send everything up, and it's basically us in Reno.
Right,
So I'd really like to be us.
that's right.
So it's just like
We have adopted the battle cry "Beat Reno," so we're
exactly
we're
we
solidly
want.
in the camp.
So it's just like I'd love to get that. It's one of those things like I can see what needs to be done. I just don't have the time to do. I wish I could do it myself, and
Yeah.
I can't.
Well,
And so I'm trying as much as
communicating
I can to help them.
yeah, I mean, and just the fact of recognizing it, writing it down, like, and even in a brief way, is a huge service to a project. Sometimes people that work on it can't see the how to scale or how to scope, and it sounds like you do have some vision there. So it's a it's a big deal to be able to see those things and to articulate them. That's a huge service, in other words.
Also, just have so much sympathy for the undergrads because you just see
Yeah,
them getting ground down,
yeah,
and I'm just like they just want to
yeah,
finish. And I remember what it's like you just want to get out, and
yeah,
it's just it's like jail. It become my seniors or fifth year. It's just like a lot of them are just like I just need to get out of here, and I'm like
yeah,
I get it, but
yeah.
so it's just yeah.
I have
Anyway.
only empathy. That's how I felt. when I graduated. So, well, thank you so much, Ed. I think we'll be talking a lot more. And please feel free to put any of the questions. Just start out in general, if you know, if it doesn't look like an obvious fit, as I know we have a lot of channels. But ask away, please, and we will do our best to get you an answer and to get you any resources that might be needed. And just thanks. I'm really looking forward to seeing all of this work.
Yeah, I want to document it as quick. Yeah, well, I'll get you some stuff because definitely
Cool.
I'm grateful for the hardware and it's allowed me to do some stuff. So I'd love to get you guys something back for you, at least for the newsletter, and also
Yeah.
for a chance to show some people some stuff.
Excellent. Thank you. All right. I think Ken, you have some report.
Yeah, a little bit. The I was able to take everybody worked hard on getting the tool installed on our server. It's like a web app tool to build the source code for the polyphase filter, and that got working, and so I compiled it and was able to synthesize and run it through the implementation phase for the FPGA. So looks like it's building. It didn't get any real. There were a couple what I would think are minor not errors, just kind of warnings in the compilation. But I think those will probably be okay. So right now I'm going to be looking at stitching that into the analog devices reference design. Hoping to do that this week. The goal for this week is to take a look at that and stitch it in. So that's it.
Wow. Okay. Yeah, I'm looking forward to that. The analog devices reference design is what we're trying to start with in the remote lab for the ADRV boards and the Xilinx dev stations. So that'll be very fun to explain. So we have some experience with like compiling these and getting the basics to work. And and just let me know whatever you need help with. And then I think it would probably be good at some point to use like the system block diagram that Vivado puts out as some sort of baseline in order to draw a block diagram to do a quick presentation about like what it is that we're after on the uplink receiver. What's the basics of it working, and to go over the configuration. And if we can get something simulated, that would be huge. So I'll count me in for helping out with that. Okay, Paul, do you have any news from the lab?
I don't really think so. A little bit of effort involved in clearing up what appeared to be a licensing problem for Ken, but otherwise, it's just cranking away. I don't have anything on the immediate docket. Might have, excuse me, might have some time in the next week or so between distractions to get some work done on some other stuff, but and nothing in the immediate plan.
Okay, good. Yeah, things seem to be working, and thank you very much for helping with the various challenges. Do we figure out exactly what happened with the license server?
I think it turned out to be a license problem at all. It was a mismatch of modules being compiled with different versions. It just looked like a license issue because when it tried to go build something that couldn't be built, I'm not sure I understand all the ins and outs of what happened, but it wasn't a license server issue that had to be cleared up as far as I know.
Okay, good. Yeah, for those that are following along, we have a floating license for Vivado recently updated so that we can use some up to very recent, I think current versions of Vivado, Vitis, Petalinux, all of that good stuff. And that is something that you check out when you log into the VM. Then you can check out the license and target it pretty much any hardware out there. So this lets people use something that is normally thousands of dollars. As long as it's for open source work, it's free for folks to use. All right, thanks. I look forward to coming back over to the lab and working on continuing to work on Neptune stuff. So we're making some progress, and we picked up a volunteer there. And I think that also, Ed, you mentioned OFDM receiver. So I think that's of interest to Neptune, since it's OFDM based link. And we've been concentrating on getting the transmitter under our fingers. So any OFDM receiver will be greatly appreciated, because the transmitter, we do have a model of the transmitter in Python from Andreas Schwarzenegger, the author of the spec for Neptune, but not a receiver. So there's a potential share right there that would be very appreciated.
I'm basically working through, I guess when I got the at on Pluto, I got Analog Devices. You know, they have their SDR for Engineers ebook
Yes,
that they have allowed for download.
That's a great book.
And it's got a lot of it's really got a lot of interesting stuff into it, and it's got a set of labs, and the sixth lab is an OFDM. I'm basically using that as a guideline. So it's
Okay.
they got a whole like file set up and like how to build it. So I'm just basically following their setup and experimenting with that and
Okay.
seeing how far I can get with that. And if that's of extra interest to you, I can definitely put together a little demo of it once I got that up and running. I've started out first just doing, like I said, just to basically like using the Pluto to transmit DVB and then using an RTL SDR to take it and decode it using there's that DVB kind of like simple Windows software that just lets you that just sends out a DVB-S signal off of your like camera from your laptop. And so you can just use that to like kind of create a simple loop and use like RTL SDR to receive it and just create a simple loop in like your lab or something to test. So I've been testing that. And then OFDM was going to be the next step. So if that's something where you guys would like to see what I've learned from that and how I can apply it in the Adal Pluto context, then yeah, I could definitely put together a presentation on that front.
That'd be
And
great.
yeah, just to show you what I learned and like maybe some ways to do it because I've been balancing it between like all the resources that Analog Devices has with the Pluto since it's there with MATLAB since because as a UNLV student I got free access to that and they got a lot of resources with SDR and that even leverage the Pluto and then the other stuff is and GNU radio. So I've been trying to use those 3 points of the triangle to build up my material so I can approach it from any way. Because sometimes MATLAB just makes it really easy to kind of like break it down and analyze the signals. And Analog Devices just has very good hardware support. So I've been trying to leverage the advantages that each of those three angles gives me.
Okay. Yeah,
So,
we have essentially the same setup here, and I'm using that book as well. I'm still solidly in the synchronization section of the book to try to drill down into the 3 different ways to do synchronization, so that I could use it for opulent voice and really understand the need of for coherent demodulation on that. So I haven't gotten to the OFDM part yet. Is it chapter 6, I think, or lesson
well,
6
it's
or
lab
something?
6, but it's
Okay.
chapter I think 7 or 8.
Okay, yeah. So
it's like
you're ahead of me. So I will help make a
well,
presentation as easy as possible because it would be of great interest and would help a lot.
to be fair, I kind of cheated. I just jumped ahead and figured like I just jumped ahead. I haven't been doing it. I was like I really want to figure out how this OFDM thing works because I know it's important. And so I'll admit I kind of jumped ahead. So
I don't I don't
I'm
mind at
not doing it
all.
linear. Yeah.
No problem. Yeah, well, thank you. Cool. I'll look forward to that. All right, Matthew, you have the floor.
Oh, right. I appreciate Paul's help with getting the VM up for the web app, and so sounds like that was all successful and useful. I did submit a pull request back to the web app author. I haven't seen anything in my email, so I'm not sure that he's looked at it or seen it or wants to do anything with it so that it works again on the Streamlit app website. But at least we had it for our needs. I don't have anything else. I'm going to have to step away from my other meeting now.
Okay. Well, thank you so much for the help, and we're going to make the most of it, and we'll keep you definitely in the loop. And if you see anything that you're interested in doing or advising on, then it's more than welcome.
All right. Thank you.
You bet.
All right. Bye-bye.
Cool. Let's see. I have a busy rest of the week, so I'm giving a presentation about the 219 megahertz band, which is a very interesting allocation for amateur radio tomorrow evening. So I spent a lot of time on that. The next day is a presentation at UCSD to young professionals, IEEE group. And after that, I'm on a panel at the CHIPS Act. There's a workshop in San Diego on Friday. Saturday is a WinLink board meeting. I don't go to the board meeting, but I do go to the reception and the meeting after that because I'm part of informal part of the WinLink developer team. So that's a lot of stuff that's going to happen over the next week. So I'm not going to be diving in quite as quickly on ORI technical things. But what I'm hoping to do is after the 4th, so starting on November 5th, I'll be back in the lab, and anything that I learn at all of these different events, I will tell you all about it. You'll be the second to know. So there's been a lot of interesting things going on in the regulatory world for amateur radio. The FCC has come out with a report and order and further notice of proposed rulemaking about the symbol rate for HF, VHF, and UHF, and those symbol rate limits, which have been perceived as extremely restrictive and harming innovation in amateur radio, especially on HF, they are going away. The report and order eliminates the baud rate and symbol rate limits for HF and for data modes, and replaces it with a bandwidth limit of 2.8 kilohertz. So this is a long time coming. This has been brewing for at least since 2013, and especially got fired up in 2016. So it took a long time and a lot of effort. Been involved off and on trying to get this to happen for quite a while. And I was extremely happy to see the report and order come out. There's a couple of other regulatory things that we have our eye on, but that was kind of a big step forward. There will be opposition to it, so people will be, I expect there will be some petitions for reconsideration filed. I do not expect those to stop this from being implemented. So those of us that care about digital modes on the HF bands and on VHF and UHF as well, there's lots of good news in this particular regulatory step forward. And that's pretty much it from my end. Lots of really wonderful things going on, and I definitely appreciate all of you and the many others that are watching, and just know that your time and expertise is deeply appreciated. All right, any last thoughts or questions or comments before we close?
I have a thought on the 219 work that, well, actually on the symbol rate work, mostly on the symbol rate work, that this can be seen in an even longer context, going back a long way into the previous millennium, to make the FCC rules recognize that we're really an experimenter service and we should be allowed to experiment and not just redo the same old radio teletype that's been done by commercial use services and military services in the past. Being able to use unspecified digital codes, for instance, was a huge controversy and a big regulatory step forward for experimenting. And what we do would not be possible without those older steps already being well accepted. So I think it's worth mentioning that this is a long-term trend, and we have to, it's something like everything else in government, has to be constantly monitored and pushed in the right direction in order to make progress, and then falling back.
Yeah, things like this require maintenance and attention and consistent and persistent participation from a sort of, in many cases, it requires a pretty broad coalition of folks. And sometimes it requires funding and key people to come out in favor of it. It's exactly right. I'm hoping for more things like this to happen. Yeah, if anybody has any particular views on what else should be changed, the symbol rate rule has has gotten a lot of attention from many of us for quite a while. But if there's some other area that you can think of, then that might be worth spending some time on that as well. Yeah, looking forward to the next week and coming back in a week from now and being able to report on all sorts of different things, technical and otherwise. All right, folks, that's it for this week. I have a happy Halloween, one of my favorite times of the year. It's really nice to have a meeting on such a special holiday. All right,
Don't eat too much candy.
Yeah, I'll try not to. All
I
right,
know,
everybody.
I will.
See you soon.
Peace.